Yo. Yo. Come on, man. I'd really kind of feeling love to get this problem. Man. I don't know. I don't know if don't rush it sort of thing. Let's just savor it because this is a pretty nice, like meaty problem. It's pretty good. So let's just keep going with it. And eventually it'll be done. Whenever that happens. When it does, who can say? But we're making some pretty steady progress through it, I feel. Did I do this in the day 17? Yeah. This going. Always got to have Firefox for Jupyter Lab. Gotta have it. So where did we kind of leave off? So we were investigating this Zor interval thing. Like we were seeing if, because we were able to do it where we kind of were reasoning about Zors and like functions of Zor, like Zors of numbers and functions of Zors, and we were reasoning about sets of functions of Zors, I guess, and we were kind of noticed that you might be able to reason about intervals of Zors, and if we take a Zor of an interval, kind of, basically that's kind of a good way to think about it. It's like if we take like a Zor of an interval, do we get an interval back, or do we get a set back? I kind of want to cheat a little bit and just ask ChatGPT. If we take a Zor of an interval, will we get an interval back or not necessarily? And before I ask this, I wonder if there's just kind of like, if we can just like show a counterexample real quick. Like if we said like x is greater than or equal to 1, 2, and if we Zor this by 1, that's really the question. It's like you have an interval and of numbers, and if we take the Zor of this interval, will we get another interval back, maybe like shifted? Will we get the same basically interval back? Okay, I think we can show that we won't necessarily get the same interval back. Like say, we just have like 1 and 2. Let's just do the Zor of 1. And so let's see, 2 Zored with 1. that's equal to 3. So basically, basically we get this thing where it's like 0 and 3. 1 goes to 0 and 2 goes to 3. And, 1 and 2 are nowhere to be found. So this is a case where we don't get an interval back, and, it's a case where we don't get an interval back, and we also don't get, the same, maybe like contained, like the numbers aren't contained within the interval. Maybe the last thing I'm wondering is, will the Zor of an interval result in a bijection, or could that be lost? Like if you have an interval, let's just consider like Zoring with 1. So basically all that's going to do is it's either going to add 1 or subtract 1. So the only time you could kind of have a number mapped to both is if it's like a consecutive number, and the like kind of like lower number had like the +1. I guess it's kind of like this. It's like you have kind of 3 numbers like A, B, and C, and B does whatever, but then like C goes -1 like that. I don't think that's going to happen though, because consecutive numbers like just going up by 1, it just goes like even odd, even odd, even odd, and so even numbers are going to get +1, odd numbers are going to go -1. Yeah, this went -1 and this went +1. What happens if we extend this out a little bit? Do 3. So this is Zord with 1. That's going to go to 2. Yeah. And then like 4 is going to go 4. 4 is going to go to 5. And yeah, you're basically just going to have this crisscross applesauce kind of thing. So what about Zord with 2? Well, 2 is 1, 0. And so if we take the Zor of, how about 1, 2, 3, 4 like this? 1 Zord with 2, that's going to be 3. One, 2, 3, 4, 5. So recall we can at most add 2. Oh, it's just going to be add or subtract 2. That's it. So 2 is going to go down to 0. 3. 3 Zord with 2. It's going to be 1. Yeah, it seems like it's only plus or minus 2. That's it. So we need something a little more interesting. We need a Zor that has multiple bits. So like 3 is kind of the the smallest one, I guess. It's like 1, 2. So we could either gain both of these bits, like +3, like 0 goes to 1, 1. We could have 2. So we have these two things here, and these could do all sorts of flips. Yeah, if you have like 0, 0, if you have 0, 1, then that's going to go to 1, 0. So 1 goes to 2, gets +2. Yeah, +2. So it's basically like, yeah, you kind of take all combination of these bits. You could have like both of them. You could have one. You could have this, or you could have nothing. How do I want to think about this? Like, this is always fixed. So our last two digits could either be 0, 0, in which case it does +3. Our last two digits could be 0, 1, which in this case, this would go to 0 and this would go to 1. So this would be, so this goes from 1 up to 2, basically. So we kind of subtract 1. No, we add 1. No, we add 2. Yeah. And then we could have 1, 0. And so this is 2. And this would go down to, like, this would 0 out, 0, 1. So 2 down to 1. So we do -1. So it's kind of like looking at this thing here. You take every 1, and so this is a 2 and this is a 1. So you can kind of like gain both of these. You could lose both of these. You could lose 1. You could gain 1. So it's kind of like you could kind of looking at them individually. You could either +1, you could -1, you could +2, you could -2, or you could +3, or you could -3. Is that right? Let's just look at each of these individually. So +1, how would we do that? Is if we gain this bit. So basically, if we had like if we just gain 1. So yeah, I don't know, 0, 0, would give us no. Okay, so this is how we can't. So we don't actually necessarily. I mean, these are the only things. Like, basically, our last bits could, we have 3, we have 1, we have 0. So we go from 0 to 3. We go from 1 to, yeah, we don't gain 2. We just gain 1. We go from 2 down to 1, or we go from 3 down to 0, I guess. So it's -3, -1. I'm having trouble seeing this right now. So there's one thing here. I mean, there's only one outcome for each of these, and like these are all the possible ones. Is there no way to kind of tell in advance like what the values are going to be? Like, I guess, do we ever Zor with C? I think we do, right? We do Zor with C. Yeah, so like C can be anything. How about let's start with 5 and 6 because those are kind of important. So Zoring with 5, which is so we're Zoring with a 4, so 5. So basically our digits could be 0, 0, 0, and we Zor with this, so we get 101, 0, 0, 1. We're gonna have like 8 of these. We're gonna have a lot. All right. So we're gonna Zor 5. So 0, 0, 0 would go to 101. So this is 0. And we get a plus 5 here. 0, 0, 1. 1, 0, 0. So we went from 1 to 4. 1 to 4. So we did a plus 3. So 0, 1, 0. This is 2. And we're going to 1, 1, 1. It's basically 7, right? It's 4 plus 2 plus 1. So it's plus 5. 0, 1, 1. This is a 3. And 1, 1, 0. This is 6 plus 3. 1, 0, 0 goes to 0, 0, 1. So this went from 4 down to 1, so you minus 3. 1, 0, 1. So just going to go down to 0. This is 5 down to 0. Oh, so this is a minus 5. Minus 5er. You got 1, 1, 0. This is 6. Go down to 0. 1, 1. Down to 3. 1, 1, 1. 7. Go down to 0, 1, 0. Go down to 2. Minus 5. So there weren't any minus 1s. It was just 3 and 5 and a kind of like a minus kind of thing. What about 6? So we got that. Zoring with 5 gets you like plus or minus 3 or plus or minus 5. So Zoring with 6. 1, 1, 0. So 0, 0, 0. 1, 1, 0. This goes from 0 to 6. So you get a plus 6. 1, 1, 1, 1. So you get 1 up to 7. Again, you plus 6. 1, 0. It's 2. You get 1, 0, 0. Plus 4. 0, 1, 1. 1, 0, 1, 5 plus 2. Oh, look at this. You got 6, 4, and 2 now. Now we're getting crazy. This is going to zero out. This is 2. Let's go down 2. Oh, 1, 1. Minus 2. 6. Oh, oh, oh. Minus 6. 1, 1. Oh, oh, 1. Minus 6. So you have some plus 6s, you got some minus 6s, you got some minus 2s. You only got, and then you got 1 plus 2 and 1 plus 4. We can do that out a little bit. We can just see, just see what happens. 1, 0, 1, 2, 3, 4, 5, 6, 7, 0, 1, 2. So 0, 1, 2, 3. So 0 goes to 6. 0, 1, 2, 3, 4, 5, 6, 7. So 0 goes to 6. Well, we can just read off these. Oh, dang. Okay, so both 0 and 2 go to 6. Look at that. So we found that the bijection doesn't necessarily hold. 6 to, what is this? 0? Let's just confirm that both 0 and 2 zeros or 6. 1, 1, 0. And then 0, no, not 0, but 2 Zor 6, 1, oh, this is wrong. 1, 1, 0, 0. Okay, this is wrong. 2. Yeah, this should be 1, 1, 0. So why did I say this was 6? Well, oh, it is sit. Wait, what the? What is going on here? So somehow I knew it was 6, even though I wrote it wrong. One oh oh. It should be 4 plus 2. Yeah, so I don't really see any numbers that are intersecting. We got 0, 1, 2, 3, 4, 5, 6, 7. As you go up, both of these are plus 6, plus 2, minus 2, minus 6. Huh, do they always occur in pairs like that? I don't know, man. It's like these first half ones, they all go kind of like up. but then the kind of like last ones, they kind of go back and then like back even more. So I don't know. Then they get, I guess they span, the interval. Wait, would that work? Like, what happens if we like chopped off the left and the right? So the left. So let's just say like we don't include 0 in the interval. Then we just have like we don't have 6 anymore. And then let's go to, well we would say go to 8, and then 8 kind of has the same number of zeros. So that would give us a +6. So like 8 would go up to like +6 again. So, oh, I think I'm seeing it now. So it depends on the interval. Like basically, you're going to have this span along the, um, as you enumerate the digits of the Zor operand, those are all going to be unique. There's no, yeah, there's no zoring of like two things with 3 bits long that's going to like give you the same thing. They're all unique. So that's fine. But yeah, if you cross that boundary though, that's when you could potentially lose the bijection, I guess. Let's see. So it's like, so let's look at 5 again, like zoring with 5. So we got this. So, 0 through 7 is whatever, but let's look at kind of the values surrounding 7. Let's look at like 5, 6, 7, 8, 9, or something. Maybe like 6, 7, 8, and 9. Yeah. 6, 7, 8, and 9. So 6, 1, 1, 0. Zoring that. This goes away. This is here, and this is here. So you get a 3. So you subtract 3. So that goes like over here. 7 goes. This goes to 3. 7's not gonna. Yeah. 7 goes to 2. So this goes to like 2. Hey, is that right? I don't think that's right. 6, that zeroes out. That stays. 7, that zeroes out. That gets a 1. And then that goes to 0. Oh, no. This is -5. Yeah. It's 3s and 5s. 3s and 5s. So yeah, this is 2. So 8 now. Zoring with, yeah, so 8's going to go up. I guess that's what we really need to do. We really need to do like a full kind of half interval to half interval. So instead of going like 0 to 7, we would go, I guess maybe like 3, 4, 5, 6, 7, 8, 9, 10, 11. Something like that. I kind of don't want to do this out. I kind of just want to like code this and just print out the values. So let's say for I in range 3 up to 12, let's print I XOR with 5. Let's print I, and then we'll do this, and maybe like I minus. Let's go to when, let's find when they kind of like repeat. So 0 to 7, and then 8 up to, no, like it's like 0 to 8, and then 8 up to 16. So maybe we'll go like this up to 16. So let's just see if there's no duplicates. It spans the whole thing. Like you just never. Let's just check this for like the first like fucking like 100 numbers where we could like XOR this. For I in range 100. I don't even know. Like for J in range 1000. I XOR J. If it's ever the case that the length of nums and the length of is not equal to the length of the set of nums. Nope, doesn't seem like it. Seems like it always just. All right, so interesting. So I guess you do. If you kind of like go wide enough, then you always get an interval. But if you only take like a small enough set of it, then you might not get an interval back. Okay. Oh. I just had the thought like maybe the XOR function, part of the reason why it's less intuitive is it's not linear. Yeah. Like the and function maybe is always kind of linear. It kind of feels like it's just kind of I don't know. I don't know if what I'm saying there is like 100% right, but that was an interesting thought. So we could look at these. So we could look at these values and kind of see if we can reason on the interval. So we got B4 is, yeah, going back to our classic thing. And yeah, we have B4 is equal to B3 XORed with 5. right? 6. Sword was 6. So this is 2 to the 4, so this is 16. And this guy here is 23. So going from 16 up to 23. I mean, the interesting thing about that is it's spanning the whole. Yeah, I mean, it's spanning 6, which is only 3 bits. So this thing is going to be an interval versus let's say like B4 was only, greater than equal to 16 and 17. Then 16 to 1, 2, 3, 4, and then 17 is 2, 3, 4. And if we XOR this with 6, 1, 1, 0, it's gonna be 1, 0, 1, 1, 0. So this gets added 6 to it, 16 plus 6, and then 17 gets added 6 to it as well, and that gives us 20. Okay, so that actually still gives us an interval, but what if we did instead like 17 and 18? About that, huh? 17 and 18. 17, 1, 2, 3, 4, and then 18 is 1, 2, 4 like this. So 6 is going to be 1, 0, 1, 1, 1. So this is plus 6. This gives you 23. And then 18, this is 1, 1, 0, 1, 0, 1, 0, 0. So this thing here gives you 16 is 4, so this is 20. So basically, yeah, like 17 maps to 23, and then 18 maps to 20, and boom. So yeah, you don't have an interval. Like this stuff is like missing. But since we're starting out and it only has to be a 2, we will get an interval here. So okay. Yeah, so this still stays at and we can kind of verify that by looking at the numbers. Like we started off with B3 and then we did sorted B3 again, and we're still within 16 and 23. So now we do this. Let's do it with B2. Yeah. Okay. Still in that range. Yeah, we're still in the range because we're just XORing with C. And now we're up to B1. Okay, so now we actually should, hold on. Yeah, no, we're still we're still zoring with just 5. We're still zoring with just 3 bits. So we're still going to span the range there because it's just because the difference between 16 and 23 is 7, right? Yeah, so it's just 7 values. I don't know about A now. A is a whole different thing. We started with B1. Yeah. I guess A spans the thing. But yeah. So whatever. We're reasoning on intervals. Do I really care for this case? Because if we start zoring with C, we might not still have an interval. If we start zoring with non-zero values of C, which are greater than 3 bits in length, it depends on what these ranges are, these values are. But anyway, we found the values of A, which will basically, like, when we bit shift them by 3, it's going to give us values in this range here. And so, 16 has 7 values and 17 has 7 values. And yeah, kind of does that. So that works there. So that gives us a 2. Now, what's going to happen? Like, that gets us to the first run, but we need to go multiple runs. Now we need to output a 4. So, let's see how the logic changes, if any. So we need to output a 4. So basically B4 has to be of this form 4. So it's got to be like 1 1 0 and then like XXX like this. So yeah, it basically has to be, by similar argument, it has to be in the range 1 1 0 0 0 B4 1 1 0 1 1 1 like this. And I think just by like a similar kind of argument, we're gonna get B3. I don't think anything really changes. What is this range? This is 2 to the 0, 1, 2, 3, 4, 16, 16 and 32. So this is like 48. No, 16 plus 32. Yeah, that's 48. And then 48 plus 7 is 55. So yeah, it's just gonna like kind of do the same thing. So is this always gonna are we always gonna basically have to do the same thing here where we, yeah, it's just got to be the case that B4 is always just going to have to be, like the value that we want to output followed by anything. Like, so it has to be in the range. So to print any of these values, Hmm. So So the only kind of starting point that's changing for us is basically like this kind of prefix here. If we could just take these as like independent runs, kind of do that. So we kind of like started from this point and we got all the way up to like A is equal to basically A had a bound on it. Yeah, I mean A was whatever, like these numbers, and it produced a number in this range. And we found like the lowest A for that. Oh, yeah, we did actually test that out for all these A's, didn't we? Like right here. Yeah. So A was a range that we could do. So what happens like one time through this program? Like what? Oh, so this jumps back to 0 if A is 0. So what is the value of A? A gets bit shifted over by 3. Is that really right? Wait, what's the, oh, jump if not 0? The J and Z. Oh, it does nothing if A is 0. So if A is not 0. So I guess we want A to be 0 by the end of this. Well, what's kind of like the minimal thing? No, we do need to like keep crunching down. Um, B is equal to this. Confused how we do this. Like if A was 128 starting out, wait, what does it do? Oh, okay. So we don't need to worry about like making sure A is some value to jump. Like so, it's just always gonna so it's just always gonna jump back to 0 unless A is 0. Okay, cool. So yeah, A kind of keeps getting crunched down. So maybe this is where C is gonna come in. So it's basically like, A starts off as like 128 and it gets crunched down like the B kind of does this. A gets crunched down. I wonder if it would be more readable if I just drop these subscripts now. I'm kind of like, I feel like maybe this is causing more confusion now than it was. Let's see. So A gets shifted down by 3. Well, okay. Oh, okay. So basically just like every time we basically start, okay, so right now we're like assuming that A is the only kind of like important thing. So I'm kind of confused because it doesn't seem like A can ever grow anymore. We kind of need it to grow, don't we? Because if A is 128, then by the time it gets down here to B, like B is going to be of whatever 10xxx like that. And then yeah, B gets shifted down, but it doesn't actually get shifted down. Maybe kind of printing out like a trace of this might help. Let's see. So we kind of have this. Let's just see what this looks like. Let's say A is equal to 128. So maybe we'll say like print, kind of like just grab this stuff and we'll say and then we'll print B1 like this. And we'll print B2. And then this goes into C. Value of C, say B3 is equal to this. So say that B4. No, I guess it's B3. Say A is equal to B. B. B4. Let's say this is equal. Maybe do this on the other side. Could do this thing. I think it's like this format. Yeah. Do 4. C. Okay. We just print out like A, B, and C. What did C get set to, by the way? What's C? It's just 0, I guess. So C is equal to 0. It doesn't matter what B is, but whatever. Doesn't matter what B is, but so, and then we do it out, but then by the end of it, like what is A, B, and C? So we do A, B4, and C, I think, right? A should have gotten shifted this way. A is 16 now. That's not going to be good to get us this other thing. So where did C come in then? Like C has to be able to help us out. A bit shifted by B2. That means it's only going to go down. It means C is only going to go down. I don't see how you can kind of recover from this. This is the BST thing. Wait, oh man, I feel like I've been doing this wrong the whole time. BST doesn't say to shift it down 3. It just means to take the Just take the remainder modulo 8. Dang. Okay. So what do these actually do? Division. Okay. These division are correct. The ADV. Do we have an ADV anywhere? Yeah, ADV of 3. Yeah, cool. 2 to the power of the combo register. Yeah, so the ADV opcode 0. So boom, 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 boom. Okay, 2 to the 3. Okay, that's fine. Like that's correct. Dividing by 8 is the same as bit shifting by 3. So that's good. So what's the BST thing though? Mod 8. This should be a mod 8. BXL, bitwise, Zor, B in the literal. So it's just 1 and 5. That's fine. CDV, ADV, division. 2 to the power of the combo register. So CDV, this should be the third one, 7, 5. Yeah, you divide it by DV. Yeah. You divide it by 2 to that power thing. So 5 is B. So yeah, so you divide it by 2 to the B. Okay. That's fine. So BXC, bitwise Zor of B and C. Yeah, that's fine. Let me get rid of this. ADV 3, ADV of 3, combo, literal value, divided by 2 to the 3. So yeah, just bit shift over by 3, BXL, bitwise Zor, B divided by 6, BXL is 1, B Zor 6. And then, yeah, out. Dang, dude, this is wrong. This is wrong the whole time. Fucker, like this should have been mod 8. You just take the what the oh my god, this is wrong the whole time. So it doesn't need to be like 10xxx. Like you actually need it to be you just need to be like xxx blah 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 blah. You want to output a 2, you just have to have the last 3 digits be like 010 like that. All right, so that makes a lot more sense how you could do this, because like all these could encode like the subsequent numbers that you want to print out. So that's good. So now looking at it, you dang, nice. Okay, now we have like a whole new thing to look at. Yo, let's fucking go. Let's do this. Let's fucking do this shit, man. Like it's like let's like reason all this out again. It's like now that we've done all that reasoning and all that like hard work, maybe it'll just like pop out and be obvious now. So kind of before. Okay, now we're like characterizing before. B4 has to look like this. It just has to look like XXXX, blah, 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 0, 1, 0. Yeah, because we're going to chop off these bits and print them out. So I don't know how I would characterize that, but just kind of saying that it's in this form. And we have that B4 is equal to, I think I want to go back to the indices. B1, B1, B2, C and A, B2, B2 to B3. That's fine. Just keep that as that. B3 to B4, and then B4 goes out. So B4. So you have B4 is equal to B3 XOR with 6. Okay, and XORing with 6 is only gonna mess with the bottom 3 bits. So okay, like that's fine. So basically, whatever B is, that's cool. We can like totally ignore this shit. It's fucking shit. Like here, we can just ignore this shit. Like, get the fuck out of here, man. Just ignore this shit. Like, okay. So basically, yeah, when we XOR B3 with 6, we want to get this. So what number XORed with 6 is going to give us this? So 6 is da. So we want to XOR some number with this to give us 6. So, oh yeah, it's like, so we would just like do the XOR, and this like cancels out to 0. So we just like XOR B3, B4 with 6. So B3 is just B4 XORed with 6. A gets shifted down 3. B2 gets XORed with C. Let's just say that C is 0. So basically like B2 is equal to B3, nothing changes there. And so so this is B4 basically. And so we want to XOR it with 6, which gives us what? 100. So this is basically B3 right now. This is B2. And we have B2 is equal to B1 XORed with 5. So in order to output a 2, B2 needs to be this. B2 is equal to B1 XORed with 5 is B2. So the value for B1 that we need is B2 XORed with 5. So let's XOR 100 with 5. So this is equal to B1 then. So B1 is just equal to 1. And then we have B1 is equal to A mod 8. So we have to have it so that, so B1 is equal to A mod 8. So it's interesting to kind of like, I mean, I think intuitively it's like pretty obvious what to do. It's like, all right, B1 has to be 1, and you have to choose A so that when you mod it with 8, you get a 1. So, I mean, A just looks like, whatever, just like this, that. But if I were like to do this algebraically, if I say like B1 is equal to A mod 8, how do I do like the inverse of mod? You take something mod 8, you can't really like do the inverse of mod 8. Like A could be like some huge number, like millions and millions and millions and millions. And then you just want to like undo mod 8. Like you can't reverse that. You just kind of have to think about it and be like, all right, what value of B do we have? So yeah. So if C is equal to 0, like, are we just good? Like, do we have to like mess with C at all? A shifted by B2. Maybe we do. Because A does need to be this like really big number that holds basically kind of information about all the numbers we need to print out. And B2, we kind of have this interaction here with C. So I feel like right now it's a little much to reason through C. I don't think I'm going to do it right now, but we have certainly fixed our misunderstanding with what is even being asked. So yeah, this is a lot more straightforward now. It's actually solvable. Kind of makes sense. So yeah, we will pick it up next time and be like, yeah, with C, got to figure out how C interacts. I kind of wonder if we just could ignore C, if we could just take out C. That's kind of what I want to do next time. I would say is let me just do it now. Let me just ignore C and see if kind of pops out. Let's just take out the step with C. So let's go back to, B4 has to be basically like this in order to output a 2. 010 like this. So then we have that B3 is equal to, no, we have B4 is equal to B3 XOR 6. So in order to get B3, we just XOR B4 with 6. So we say B3 is equal to B4 XORed with 6, which is it's going to be this X thing XORed with 6. So it's bop bop. So it's bop. So it's bop 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 like this. And then, so now we have that B3 is equal to, let's kind of just say, yeah, let's kind of skip B3. Let's just say that B3 is equal to B4. Let's just say that, yeah, it's 0, like C doesn't exist, it's just 0. So you basically just have that B2 is equal to B3 for now. So it's still going to be basically of the same form, like 100. And I mean, just to confirm, just to play it out kind of forwards, if you XOR this thing with 6, then will you get 010? Yes, you will. So yeah, so now we have that B2 is equal to B1 XOR 5. So if we want to get B1, that just equals B2 XORed with 5, which is equal to this thing XORed with 5. 5 is 101. So it would be this X thing 101, 001. It would just be 1. B1 is equal to that. And in order for, that's cool. So B1 is actually only ever just 3 digits. B is only ever 3 digits. Like you actually don't even have to mess with this. So like A is just like whatever its values, and it's like 001. So as long as A ends in 001, then we'll print out a 2 kind of in the first pass here, assuming that C is equal to 0. This is the thing that picks us up, though. Because like A is this big number that does encode like all these, all the values that we want to print out. And we shift it over by B2. So yeah. Okay, maybe that's a good place to stop because we did verify that if A just ends in that thing, then we good. Like, what's a number that ends in 001, for instance? How about 1001, like this? This is just 1 plus 2 to the 1, 2, 3, 8. So this is 9. So basically, I would claim if A is 9 and C is 0, then we will print out a 2. 9. Change this to modulus. Okay. So B1. Oh, no, 8. Okay, so A mod 8. Five. B2. Basically, yeah, C is 0. A gets shifted over by 3. Do it with 6. This should be modulus as well. Yeah. So, why do I keep doing that? Yeah. Oh, what? Yeah. 8. Yeah. Okay. Yeah, that's good. But if we set A to a bigger value, like 111111101, like this. Let's see. A is going to be big. B2 is going to not be big enough potentially to completely destroy A. So we're going to have to take into account C. Like C might be big, so yeah, C is going to be tough to reason through. All right. Thanks, guys, for watching. See you later. Peace.